Hi everyone, in this video you'll be learning about sorting algorithm called insertion sort. So it starts from the second element at index 1, and if the element is smaller than its preceding numbers, then it is swapped with its preceding number. So in this case, the index is at 1, so these two numbers are swapped. So what happens is that 1, 5, 3, 7, 13, 9, and 12. And at index 1, because again, now because this number is greater than its preceding number, so this index increases. So until the number at index j is less than its preceding number, so until it finds its preceding number less than the number at index j, they are swapped. So now it's 5, and because its preceding number is smaller than this number at j, so 1, 3, and 5, and now because its preceding number is greater, smaller than the number at index j, so this index increases. And because again here 7, 13, 9, 12, index j, the number is greater than its preceding number, so the index increases. And when it's at index 4, the preceding number is smaller than this number, so it increases again. And at index 5, the number 9 is less than its preceding number, so they are swapped. 13 comes here and 9, and because this is less, this number is less, so it stays here. And 7, 5, 3, 1, and this time it is index j increases, and here, and because number 12 it is smaller than its preceding number, so they are swapped. 12, 13, 9, 7, 5, 3, 1. So let's get to code. So we gotta so to code, I'm going to use C, because C it is at low level, so it shows the what is happening that in the behind the scene, that's like hidden when you are using later languages like such as Java or Python. They have higher level of abstractions. So we're gonna first assign numbers 5, 1, and 3, 8, and 12, 15, and 9. And the size, you assign size of array divided by size of array O. And what it's going to return is that the number of all the elements stored in this array. So size, check the number size, and let's learn. And this C file is saved in C drive and demo folder, and cc insertion sort.c. But it shows number 7, 1, 2, 3, 4, 5, 6, 7, and there are 7 elements. And to print all the arrays, void print array, let's define function int array int size less than size, you increase index I, print f, and um, and if you call this print array function, it's gonna show all the elements stored in array. So compile again and run the code. So it shows the numbers before sorting. Before sorting. And as we have seen, let's remove these numbers and let's reinitialize with new numbers 5, 1, 3, 8, 12, 15, and 9. 5, 1, 3, 8, 12, 15, 9. And remember what we did first is that we started from the second element, so you set this index as j. Set index at j, and what we gotta do is that while this array j is greater than array j until array j minus 1 is greater than array j. For example, let's try with another number. So 1, 5. I'll change it. I'll swap this, and for ease of explanation, so 1, 5. So what we'll do is that we'll keep increasing the index j until it finds the number that its preceding number is larger than the number at index j. So while this array j minus 1, array j is greater than array j minus 1, you keep increasing j index. So at this time, if you print out number at index j, let's check the number. It's array j minus 1, j five. Let's try with printf. So actually there was a mistake because I didn't pass the argument j. So let's check again. So it's 2. So if you see here, index j is increase to 2. And what you gotta do is that, as you saw earlier, you need to um, move the preceding number 1 position forward until the number at index j finds its preceding number smaller than this number at index j. So I'll assign this number at index j into a variable called smaller, and let's declare a number smaller and save the array j. And while let's declare another variable called I and assign j, and until let's and array I minus 1 is less than smaller. So add array I. What we'll do is that, as you saw earlier, we will move this to 1 position forward to here, and array I will be assigned with array I minus 1, and you keep going this by decreasing index I. So once this is finished, what you need to do is that you need to push this the original number at index j, which is 2 currently, to this index that will be the index I. Once it is moved 1 position forward and that it is decreased, and if the condition is false, then index I will be the one that's 1 position back, that has just moved 1 position forward. So here array I will be assigned with smaller, and let's print out this by calling print array function array size, and let's check whether the sorting is correct. So 153 153, and it's maybe let's check. So this condition actually is wrong. Smaller should move until this array I minus 1 until the preceding number is greater than the smaller. So let's try again. So the original number before sorting 1 5 3 8 12 15 9 has changed to 1 3 5 8 12 15 9. So from here, what we need to do is that so this number comes is assigned at this index, and because at this time the index at j is still at index 2. If you see, j is at index 2, and because this this condition while array j minus 1 is less than array j becomes true again, so j will be keep increasing 2 up to 3 and 4 and 5 and until 6. So 8 12 15 and 9, and what will happen is that 15 will come to here, and because when this number is larger, it will move one position forward again, and at here, because this number 9 is not smaller than its preceding number, so it will be assigned here, and 1 3 5 A is all this sorting is finished. And let's try again. 4 is 4, and because we are not sure yet when we are gonna finish this iteration, so we gotta repeat this process by increasing count into CNT 0, and if CNT is greater than 0, I'm gonna break this rule, and I'll keep increasing CNT. And let's run again and see what happens. And the original number 1 5 3 8 12 15 9, 1 3 5 8 12 15 9, and after one more iteration it has finished, and now it's at index J, and we may have more numbers backwards, and when we are not sure when to finish, you can see that at index J is all sorted, and if you see that the number J less than J at index 6, it means that it should be finished when it gets to the number which equals size minus 1, because as you saw the size is 7, so we'll change the condition as well. This size is less than not size, while J is less than size minus 1, then when J gets equal to this sign minus 1, this turns first, condition turns first, and this repetition is gonna stop. So let's remove this centi variable, and by printing fj, let's check again if it's sorted well. So 1 3 5 8 9 12 15, the original numbers are sorted, and let's try with other numbers to be sure that our algorithm is correct. 1, maybe 5, 1, and 13. Let's compile and execute again. So as you see here, the original number 5 1 8 13 12 15 9 has been sorted as to 1 5 8 9 12 13 15, and as you see that J it should stop at when J gets equal to the size minus 1, and if we got more numbers after the last index 19, maybe 20 20 and 13, and let's compile and run again. We see that index J is tops, the root tops, and the original numbers 5 1 8 13 is sorted 1 5 8 9 12 13 13 15 19 20, so it's correct. And let's try with less number of elements. Let's get to 5 1 8, and let's try again sorting, and 5 1 8 is sorted 1 5 8, and what if they are already sorted 1 5 8? Um, now it's correct, and let's try with two um, numbers. Yes, this is correct. And what if they're in the reverse order? Now it's incorrect. They are not sorted, and the reason is that because this j is equals 1, which is size minus 1 when there are two number of elements. So you need additional condition after this, or array 0 is greater than array 1, the next element of array 0. And if you see the result, it is or should yes, 151 is sorted as 15. And let's um put this out and outside the loop, and let's see how they are sorted after insertion sort. And let's remove this j, and let's check again the earlier progress, and see 51 after insertion sort is sorted 15. And let's try with last 15, maybe 7, 2, 13, 15, and 6. And this time, yes, they are sorted correctly. 7, 2, 1, 13, 15, 6 is sorted to 2, 6, 7, 13, 15 in ascending order. So up to here, we've learned how insertion sort works, and we've coded with in C. And yeah, so I'm going to finish off here. Thanks for listening. Goodbye.